We're going to try to write this in logarithmic notation. Firstly, if you're trying to write in logarithmic, you better have a log. What is your base here, ladies and gentlemen? 9. So where's the 9 go? Option 1, option 2, option 3? Option 1. Notice how it's a little bit below the log. Okay, it is a subscript. So when you write in your paper, don't just put log 9 at the same level. That 9 goes a little bit below it. Do you notice how I've written it? This wasn't a mistake. It's below the log just a little teeny bit. Do you guys see that? Mm-hmm. So don't write it right next to it. That's a little mistake there. So we got log base 9. Okay, now what number goes here? This is the key part that you got to know. Most people are going to be able to get the base just fine. It's this one that people mess up if they make any mistake at all. Is it going to be the 3 or is it going to be the 729? 729. Yeah, this shouldn't look exactly like this, right? It shouldn't just have a log in front of it and have it right. Okay, that's not the same thing. It's got to change a little bit. And what we know is that the base does go here. The exponent, though, goes over there. So we could say log base 9 to the 3rd power gives you what's right there, 729. Are you guys okay going that way? All right. It's different, isn't it? It's something unique for us. Let's try a few more. How about 3 to the 4th equals 81? Let's write that one. So you tell me log base what here, folks? Log base what? So 3 is going to go right here. What number is going to go here, the 4 or the 81? 81. And that gives you what? 4. Notice how they do say the same thing. This says 4 is the power to which 3 is raised in order to get 81. 4 is the power to which 3 is raised in order to get 81. They say the same thing, it's just a different way to write it. Let's try a few more here. 2 to the negative 3 equals 1/8. Tell me the first number I'm going to write, please. 2. As they go at the same level, a little bit below the log. Which one? So 2. What number is going to go right here now?
1/8.
1/8 equals? Negative 3. Because that's your power. By the way, that is a true statement, right? 2 to the negative 3 equals 1/8. That'd be 1 over 2 cubed or 1 over 8. Hey, what's a 1/3 power mean again? Oh, this is coming back to you, this chapter 10 stuff that we had a couple chapters ago. What was that? A cube root of 7. So, that's a true statement. Let's see if we can write this in logarithmic notation. Everybody in here, what is your base, please?
7.
So we should have log base 7. For sure, that's absolutely right. Can you tell me what goes on this side of the equal sign, everybody?
1/3.
Where are you getting the 1/3?
From the power.
Aha. And the cube root of 7 must go right there. It says 1/3 is the power to which 7 is raised in order to get the cube root of 7. We'll try one more together. I'll give you a couple on your own and we'll move on. You know, right now we're actually, have you noticed we're not doing any math? We're really not doing any math. I mean, I asked you a couple questions here. But really, this is all just symbolic translation. You're translating from exponentials to logarithms or logarithms to exponentials. Have you noticed that? We're really not doing much except translating here. So really, it's all about symbols. Does it matter if I give you a pi up there? You should still be able to translate this. So let's go ahead and try that. If I'm translating this, of course, in logarithmic notation, I've got to have a log. You just need to be able to identify your base and your power and where those things go. So what is going to go right here for me, please?
5.
Good. What's going to go right here for me?
Y.
The y. And over here? Good, because you're just making a base go here, a power go here, and what the base to the power equals goes right there. It's a different way to write your exponential. Okay, try 2 of these on your own. Let's do 5 to the negative 3 equals 1 over 125. I want you to translate that as a logarithm in logarithmic notation, and this one. Aren't you glad we don't deal with that stuff for real in this class, huh? That'd be crazy. Although I'm sure you can handle it. Well, we're supposed to have a log in each case because, of course, we're dealing with logarithmic notation. We're translating exponentials, these are all exponentials, into logarithmic notation. That has that little log in front of it. Again, you just got to find out what your base is, put it in the right spot. Find out what your exponent is, put that in the right spot, and you'll have this thing down. So in our first case here, this is going to be log base what?
5.
Good. Log base 5, what goes here? Equals how much? Here's how you say this again. Practice this with me in your head. You'd say log base 5. Say it, say it.
Log base 5.
Of 1 over 125 equals negative 3. Say that. Log base whatever of something equals. You don't say log of 5 of. This doesn't work. It doesn't flow right. It doesn't sound good, right? Say log base 5 of 1 over 125 equals negative 3. It's how we say these logarithms. This would be log base 7 of cube root of 7 equals 1/3. That's how you say these logarithms. Okay, last one we'd have log base what?
Pi.
Oh, that's weird. Log base pi of equals
7.
perfect. That's exactly how you run. Raise your hand if you feel okay translating between logarithm and exponential and backwards. Good for you. That's fantastic. Now, could you, since you now should have a decent idea about what these logarithms do, could you find out what some missing information is? For instance, if I ask you that question, can you tell me what that is? If you had to think about it. What does this stand for? Is this a base? Is this a power? Or is this what a base to a power equals? That's a power. That's a power. It says, what this says is, what power do you got to raise 2 to in order to get 8? What power is that? 3. 2 to the 3rd equals 8, right? So you know for sure that this right here, that's got to be a 3. Has to be. Otherwise this thing's not going to work. How about this one? Log base 3 of 1/9 equals what? Oh. Well, here's how you think about this. 3 to what power gives you 9? 2. But it's on the bottom of a fraction. How do you? It's going to be negative 2. You see why it's negative 2? 3 to the negative 2. That's going to give you 1/9. That negative will move to the bottom of a fraction. 3 squared is 9. Well, how about this? Don't say it out loud, just think about it for about 10 to 15 seconds. I want you all to kind of think for a minute. Log base 25 of 5 equals what? How can you get from 25 to 5 with a power? How can you get from 25 to 5 with a power? It says 25 raised to what power gives you 5? What do you think? Can you square 25? It's going to give you 625. That's not right. How do you get from 25 to 5? I hear some people say square root, some other people are saying 1/2. Is that the same thing? However, you can't write this, right? You can't just write that, because that's not a number. All right, we need to go, oh, it's square root. Yeah, it is a square root to get from here to here. You just need to know how to represent that as a power. So if a square root is the way you get from 25 to 5, then that means that this thing is a 1/2. And in fact, 25 to the 1/2 equals 5. Why don't you try this one on your own? Tell me what that is. Just write on your paper. You don't have to say it out loud. Have you found it? 2 to what power gives you 1/8? Have you thought about it? Okay, the way maybe you think through this instead of just jumping right into it, think about how you get from 2 to 8 first. What power gives you that?
3.
So if this was just an 8, you'd have a 3 right there. But you have 1/8. How do you change that to the bottom of a fraction? That's with that negative exponent. So that's going to be -3. How many people thought about -3? That's good, all right. That's most of you. Now there's another thing that we can do. I pretty much just had you do it. We're going to solve some of these logarithms. Talk about solving. You did it in your head just right now. You did several of those by yourself, right? It wasn't too bad. We're going to learn that in order to solve your logarithms, one very nice thing that you can do, instead of just thinking about it in your head, since we have a variable up there right now, we could actually write these as exponentials and solve them. So in order to solve a logarithm, what you're going to do is set it up as an exponential. How are you going to solve logarithms? Exponentials. You know how you solve exponentials? Logarithms. It's their inverse operations, right? I want you to think about this. When we solved the inverse of an exponential, we got a logarithm. Doesn't that make sense? If you found the inverse of a logarithm, you know what you're going to get? An exponential. Inverses undo each other. How do you undo multiplication? Division. How do you undo addition? How do you undo a square root? An exponent of 2, as a matter of fact. You square it. Does that make sense? Because you do that because they're all inverses. Now, the way that you're going to get rid of an exponential is with logarithms, and the way you're going to get rid of logarithms is with an exponential. Because those things are inverses, they work just like multiplication and division, or addition and subtraction, or squaring and square rooting. They undo each other. So as long as you can translate, that's why we spent so much time just translating right now, as long as you can translate from a logarithm to an exponential, or an exponential to a logarithm, you're going to be able to solve these things. You ready to see how that works? So now that we have a variable up there that we can work with, let's go ahead and see if we can write this as an exponential. So your first step here is to write as an exponential. So if you see the word solve and you have a logarithm, the first thing that should be in your head is, oh, exponential. Try that. So let's go ahead and do that. What's your base here, folks? So I would write 2. To what power? The x or to the 4th? 4. Equals, oh, hey. Hey, look at that. X is already by itself. Can you tell me what 2 to the 4th is?
16.
So as soon as you write that as an exponential, that's a lot easier to think about, isn't it? Instead of trying to do that in your head, you go, oh, yeah, okay. That means x equals 16. And if you go back to the logarithm, it says 2 to the 4th should give you 16. Does it work?